Hello and welcome to this video about graphing quadratics, a recap. So the purpose of this video is just to kind of get you back in the swing of things, if in case it's been a long time since you've looked at quadratics. Just to remind you some of the different forms that we have, what we're trying to find here, and ultimately how you find this information. So first, we'll talk about the different forms. There are three forms I'm going to address. The first one is standard form, and standard form is where we have f of x equals ax squared plus bx plus c. Then we have vertex form, which is f of x equals a times the quantity x minus h squared plus k. And the reason why it's called vertex form is because the vertex is at h comma k. And then finally, we have a form that we haven't talked about too much recently, but maybe, it makes sense when you think about what the words are. That's factored form. And that's where we have a quadratic equation given to us in something that looks like x minus a times the quantity x minus b, and it could be plus or minus, to be honest with you, but that's where things are just broken down in their factored form. And so those are the three different forms, and each of those forms gives us a little bit of different information, but ultimately you can gain all the information by manipulating these things in their different forms. So let's first of all talk about what it is we want. So if we're going to graph these things, there are a few things we need to know. The first thing that helps is the direction. Now, the fancier way to talk about direction is concavity. Concavity. And you have concave up, which goes like that, and you have concave down. All right? And so it's direction. Is this thing going up or is this thing going down? Second thing that we really need to know is the axis of symmetry. I'm just going to abbreviate it as sim. And that's where the parabola is split in half, and we're able to use some points to find points opposite of it. And part of knowing the axis of symmetry is also knowing where the vertex is. So that's something else that's kind of key. And then there are two more things that help us with finding points. So you want to know where the vertex is. You might also want to know where the x-intercepts are, if there are any. That's the trick, is that there will not be x-intercepts. And finally, the y-intercept. And so these are some things that we're looking for, because each one of these gives us some information that helps us plot some points. And so now what we're going to do is just take a quick look at some examples just to find out what some of these things are. I'm not actually going to graph them for you, but I'm just going to kind of show you how to extract that information. So here we have something that's given to us in standard form, not vertex form, standard form. And so since it's in standard form, what we have to do is, first of all, figure out what A is. A is 1. And so what that tells us is that this parabola is going up, or you could say it's concave up. So we know that much. Since it's also in standard form, we can look at C, which is 8, and we know that the y-intercept is going to be at 0, 8. And that's pretty much all we get from standard form straight up. Now, if we want to find the vertex, we have to do this negative b over 2a trick. So negative b over 2a, and then we'll plug that into the function, and we'll find out what that is. And so, let's see here, negative b over 2a is going to be equal to negative 6 over 2 times 1, which equals negative 3. And so f of negative 3 is equal to the quantity negative 3 squared plus 6 times negative 3 plus 8. Let's see, so that's 9 minus 18 plus 8. That's negative 9 plus 8, and that's going to be negative 1. So we know that the vertex is at negative 3, negative 1. So So right now we have enough information to find 3 points because we have the vertex and we have the y-intercept, which we could then use the axis of symmetry to find a point on the other end of it. And then just because we can, we're also going to talk about how to find the x-intercepts. Now, x-intercepts might also go by something or another phrase, another word, and that is roots or solutions. And so these are all referring to the same thing. So x-intercepts, roots, solutions, all one and the same. Now, to do it to find the x-intercepts, we want to do these only for a few parabolas because some of them are more difficult than others. This one I think will be easy enough because we're looking at x squared plus 6x plus 8. We take it, we set it equal to 0. And the reason why this is easy enough to do is because we can actually factor this one to get x plus 4, x plus 2 equals 0. And what that means is that the roots or the solutions are x equals negative 4 and x equals negative 2. And those are points negative 4, 0, negative 2, 0 that we can then plot. And so that's how we can extract all the information from standard form. Now let's take a look at another form. Let's take a look at vertex form. So again, we can look at A, and A is negative 1. So that means this is concave down. And since we're in vertex form, the only other thing we can pull from it really right off the bat is the vertex, and that's going to be 7, 4. And then if we want to find some more information, we have a couple of options here. So I'm going to start off with the y-intercept. Because when you find the y-intercept, and you're always guaranteed to have a y-intercept, you're not always guaranteed to have an x-intercept or even have two of them. But once you find the y-intercept, you can find the point on the other side of the axis of symmetry. So that's probably a good one to spend your time on. In order to find the y-intercept from vertex form, you have to expand it out. And so what that means is I'm actually going to FOIL out my x minus 7. And so I'll have x squared minus 14x plus 49. And then plus 4. Now I'm keeping parentheses around because I have the negative sign right out here. So now I'll distribute the negative sign, negative x squared plus 14x minus 49 plus 4, negative x squared plus 14x, and then let's see here, that'd be negative 45. I now know my y-intercept is at 0, negative 45 because I've expanded it out and I had to find out what c was. Now to find my x-intercept, I have two options. If I haven't done all the work already, what I can do is simply set this equal to 0. So negative and then x minus 7 squared plus 4 equals 0. And again, this works out well if you don't have to deal with any square roots or decimal approximates because sometimes those, technically you can plot those on the graph, but I don't know if they really help you plot points on the graph, especially compared to just integers. But anyways, solve for 0, we subtract by 4, subtract 4. We're now looking at negative x minus 7 squared equals negative 4. Now, one thing I have to warn you about is if this negative sign didn't exist, at this point in time, you're done. Like, there is no solution. You can't, square something to get negative 4. But the trick, and why textbook companies and tests and quizzes can make it difficult, is putting a negative sign there. Because then you have to divide by negative 1, and you get x minus 7 squared equals positive 4. And conveniently, positive 4 is a perfect square. So we can take the square root of both sides, and we get x minus 7 is equal to plus or minus 4. So x will equal negative 4 plus 7, or x equals 4 plus 7. And so we'll have 3 or 11. Okay? Which we could also find out, or actually no, so we'll just leave it at that. And so now we have some x-intercepts. So we are good to go there. So that's how we find all this information from vertex form. You can extract the vertex easily. You have to do a lot of work to find the y-intercept, and then to find the x-intercepts, you solve and set equal to 0. Finally, let's talk about factored form. So factored form, this right here is going to tell you what a is, if you will. A is going to be -1, and so that means it's going to be concave down. And then you could also tell what the x-intercepts are going to be from factored form, and so that's one convenience you have with this form, and that's going to be -3, 0 and -10, 0. So we know that much, and that's all we get. To find everything else, we have to do work, all right? And so if we want to find out, like maybe it's vertex, we got to FOIL that thing out. And so we'll get f of x is equal to -x squared, 3x, 10x for plus 13x, and then plus 30. Then we put negative signs on or we distribute the negative signs. So -x squared minus 13x minus 30. And we get that c equals -30, meaning the y-intercept is at 0, -30. And then if we want to find, at this point, if we want to find out what the vertex is, we have to do the whole -b over 2a thing. And we've already done an example like that, so to save some time, I'm not going to do that. But this is just to show you how you can find all this information regardless of what form the original equation is given in, whether it be vertex form, factored form, or, wait for it, standard form. So good luck with your homework, and let me know if you have any questions.